Welcome back to Let's Unbound. We are moving forward with FRQ 5 from the AP Calculus AB 2025 exam. This is another non-calculated question and it's packed with some very common traps and key ideas that you must know. So keep your notebook and pen ready and make sure to solve along with me as we go through the problem step by step. So this video will not only help you crack the question, but also it builds confidence for similar problems on the test day. And as always, if you have any questions, drop them in comments. We are here to help. Let's jump into FRQ 5. Okay, this is acceleration velocity position, completely based on it. And yes, after this question solving, you will be having a very clear idea on this particle motion velocity acceleration. So here we go. Two particles H and J are moving along the x-axis. For 0 to 5, it's about time t. The position of the particle h at the time t is given by xh of t is e power t square minus 4t. And the velocity of the particle j at time t is given by this. Okay, so for 0 to 5, position of the particle h is given, the function, and velocity of the particle j is given. Now, A part, find the velocity of h at time t equal to 1. So instantaneous velocity. And you need to show the work. During what open intervals of time? I'm at B now. So during what open intervals of time for 0 to 5 are the particles h and j moving in opposite direction? Give reason for your answer. Okay. So in this particular timestamp, when they are moving in opposite direction, we need to analyze this. And C part, it can be shown that Vj prime of 2 is greater than 0. Okay. Is the speed of the particle j increasing, decreasing, or neither at t equal to 2? Give reason for your answer. So Vj of 2 is greater than 0. Velocity prime, that is acceleration, correct? And we need to answer for that question given with the reason. Part D, particle j is at position x is equal to 7 at time is 0. Find the position of the particle j at time is 2. When t is 0, it is at 7. When t is 2, where it will be. And we need to show the calculation here. Okay, here I'm going to break it down for you. Find the velocity of the particle h at time t equal to 1. Okay, so what is given to me about h's? Position function is given. X h of t is given to me. So let me take it. But they are asking about velocity. What will you do? Position is given. We need to find velocity means differentiate. Differentiating position, rate of change of position is the velocity. So rate of change is just differentiated. If you differentiate on both sides with respect to t, right? So you will get h, actually you will put xh prime t, correct? That's nothing but velocity ht. Okay, equal to, how will you differentiate e power some function of x. So copy the function. That's the first thing whenever it's e power times the differentiation of whatever is the exponent f prime x. That's it. But here we have to deal with t. So copy that first, e power t square minus 4t times whatever is there differentiated. So t square minus 4t differentiation is t square is 2t minus 4t differentiation is 4. I'm going to write this in simpler manner. Vh of t is 2. If I take 2 common out, it's 2t minus 2, then e power t square minus 4t or a multiplication. Okay, right. So we got Vh of t. Velocity at any time t we have, we need to find a t equal to 1. So all we need to do is, what is Vh of 1? Vh of 1. 1 is just plug in 1 wherever t appears. 1 minus 2, e power 1 square minus 4, 1. And simplify this. 2 times negative 1 times e power 1 minus 4. 1 square is 1, 1 minus 4 is negative 3. So it's negative 2. E power negative 3 means you can take it to the denominator and make the positive exponent. This is just an optional one. This one, or you can just give minus 2 e power negative 3. Both will be fine. Got it? So that's the answer for part A, and we are moving to part B now. Okay, we are in B part. During what open intervals of time t, 0 to 5, the particles H and J are moving in opposite directions. Give a reason for your answer. Okay. Uh, when a particle is moving in a direction, so which direction, right or left, to determine this, we will use velocity. So you need velocity of both the particles. VH of t, we just now found it in the previous problem, the first problem A, which is 2 times t minus 2 times e power t square minus 4t, right? And then Vj of t, we need velocity of j is given in our main description. 2t into t square minus 1 the whole cube. So 2t t square minus 1 the whole cubed. Right? And if they are moving in opposite direction means one velocity will be greater than 0, other will be less than 0. So we are going to do a combined side diagram for this. For that you need critical points. Critical points means for which your function becomes 0 or undefined. Here only 0, not a rational function, right? So critical points is when I choose 2, this factor will never become 0, correct? So this would be t equal to 2 when you put VH of t will become 0. That's the only critical point. Now coming here, critical points. When you put t equal to 0, yes, the function will become 0. So t is equal to 0. And when you put 1 in next factor, I'm looking upon this t square minus 1. When you put 1, it will become 0. Don't forget, when you put negative 1 also, it will become 0. Okay, but this is not affecting us here because we are just doing it from 0 to 5, correct? So this is not needed. Of course, that is a critical point, but it's not useful for us in this problem. Right, and now combine the sign diagram. So make the sign diagram, please. And the 0 to 5 we are doing. And insert your critical points wherever they sits. So 0, 1 and 2, 0 is there, 1 and then 2. Correct? Now sign diagram, above part is for VH, below for the velocity of J. And let's go with sign diagram now. Okay. So velocity of H from 0 to 1, you take any number like 1 by 2 or something. This is positive. This is 1 by 2 if you put, it will be also positive. Okay, even if it's e power negative 5 you got. So 1 by e power 5 is going to be positive. So that is also positive. Only thing t minus 2 will determine the entire sign. This is positive, this is positive. T minus 2, when you put a half, right? Your half is to the left of 2, so of course it's negative. Okay. So totally it's negative. Positive into positive, negative. Then 1 to 2, VH of t, 1 to 2, we can take some value like 1.5. Of course, it's positive, positive, only this middle sign. So if you put 1.5, then also it's negative. Maybe I won't use this V, okay, negative. Because that 1.5 is also to the left of 2. And you're going to put it in that means it's negative. Then of course, this will be positive. Because it's right of 2, so it will be positive. Whatever value to the right of 2 is subtract 2, right? That common thing. Okay, now we are into Vj of t. Between 0 and 1, if you put some point, like 2 is positive, into what? Into what? And we are cubing it here. So 0, like for example, t is t only. I am taking positive, so this will be positive. So plus times, what about this? 0.5 minus 1 the whole cube. Okay. I'm picking 0.5 from this means, and I'm plugging in here. 0.5 square is again 0.25. Isn't it? So that minus 1 will be a negative 1. Correct? Or you can split it up for an easier way. T minus 1 cube into t plus 1 cube. Do you remember this? Right? So you can use this sign technique. If you got a first time, rest is easy. So 0 to 1, we are putting some value. And that would be, for example, 0.5. 0.5 minus 1, it's left of 1. So it's negative. 0.5 you put here, it's positive. And also we are cubing. Make sure to consider it. So positive, negative, positive is negative. Okay. And now 1 to 2, I'm putting 1.5 minutes. Anyways, it's positive. This will be ahead of 1, so it's positive. Positive. This is, of course, I'm adding with the positives, so positive. Everything is positive. And here it will be 2 to 5. For example, I can pick 3. So 3 minus 1 is positive. 3 plus 1 is positive, so positive. Right, so that's it. And we got a band. Okay, here they are moving in same direction, I'm telling, 0 to 1. This is also moving left. Minus means moving left. Here I will tell they are moving in opposite way. VH is moving, leftwards, and this is moving rightwards. This is what I'm looking for. And here both are moving in same direction, that is rightwards direction. Okay, so that's it. But I'm explaining this in a very stretchable way, but you can make it very simple when you're solving on your own, right? Your brain time and your writing time, that will be very quick. So here, and we got the answer, H and J moves in opposite direction. Opposite direction in 1, 2 open interval. We don't know what exactly 1 and 2 they are zeros, right? Okay, so give reason for your answer. All over this sign diagram is being a very standard reason here. But still you can say velocity of H is left, that is less than 0, which means it's moving leftwards, and J is moving rightwards. It has a positive sign. So they are moving in, and other parts, they are not in that way, right? So you can explain that. Now we are into part C. It can be shown that Vj prime of 2 is greater than 0. Is the speed of the particle J increasing, decreasing, or neither at time t equal to 0? Okay, one clue given, and there is one question given. Okay, so speed increasing. Speed is rate of change. What is the rate of change? That's the question. So speed increasing if it's same sign, if both have same sign, what both? Velocity and acceleration. Vj is velocity and Vj prime is acceleration. Got it? Right. So if both are having same sign, they will speed is increasing. If both having a different sign, they are decreasing. Okay, and here we go. Vj prime of 2 is greater than 0. What does it say? Acceleration is positive. Okay, then what is Vj of 2? We need to find it. Do we have any information about Vj of velocity of G? Yes, we have. It's given function. So I'm going to use it. Okay, when you put 2, what happens? And we need to check that. So Vj of 2 is, that's the function, Vj of t, 2t, t square minus 1 the whole cubed. And we need Vj of 2. 2t is 2. 2 square is 4, 4 minus 1 the whole cube. Anything, everything is positive, right? So it's greater than 0. We don't want actual number here, so it's greater than 0. And we can see velocity is also positive. So both have same sign, right? We can exclude it, sorry, we can include it as both have, we can conclude it actually, as both have same sign. That's the reason. Speed of particle J is increasing. Increasing. That's it. So C part is covered. Now we are moving into part D. Okay, here we go. Particle J is at position x is equal to 7 at t is 0. Find the position of the particle J at time t equal to 2. Show the works that lead to your answer. Okay, so how can I find actually xh of t is given to us? So finding question is very simple. But what about J? They directly give you the velocity of J of t is 2t t square minus 1 the whole cubed. From velocity, you need, the question is all about finding question. I need a question function. So velocity to position is integrated, correct? So I'm going to integrate it on both sides and definite integral because time t equal to 0 is given and t equal to 2 is given. So it's a definite integral. And here we go. Integral 0 to 2 Vj of t dt equal to what it will give you, integration of Vj of t is position xj of t, and you will apply this integral. And I'm going to break it down like xj of 2 minus xj of 0. Correct? That's what we will do in integration. But I want what is xj of 2. So let me make xj of 2 as a subject. Xj of 2 is equal to, this will shift to the other side. So xj of 0 plus 0 to 2 vj of t dt. Okay, so all I need to do is what is xj of 0, and I need to find 0 to do this integral. Okay, what is xj of 0? This is what given. Xj of 0 is 7 to us given. So 7 plus this value we need, and we need to use the integration here. Okay, let me do it here. Integral 0 to 2 vj of t dt is nothing but integral 0 to 2 t square minus 1 the whole cube dt. The product of two function. First, let's go for u substitution. When your u is, take the complicated stuff. The general mistake, the common trap here is, many of you will be using this as, okay, u as this cube. Okay, don't take that. It will be much more complicated. If it's a cube function or anything raised to the power, the part we need to take as u is just the base. Okay, not the whole cube. Okay, so u is t square minus 1. So what is du? 2t dt, correct? Okay, and one more thing. So in u substitution, if you see your du part in your integrand itself, it's perfect. Okay, so yes. Now also we are using definite integral, right? So this is the limits for t. When t is 0, what is u? You plug in a 0 here. So 0 square minus 1 is 1. So I need to replace the limit with, sorry, negative 1. When t is 2, what is your u? U is 2 square minus 1, which is 4 minus 1, which is 3. So everything will change into u now. Negative 1 to 3. 2t dt can be written as just du. And t square minus 1 can be written as u cube. So basically, it's u cube du. Make sure to, don't forget to change the integrals also in form of u. Okay. And that's it. So minus 1 to 3, sorry, we need to integrate it, right? U cube integration is u power 4. Just raise to 1 power and divide by the number. Minus 1 to 3. And then plug in and solve for it. 3 power 4 by 4. Subtract. Lower limit is minus 1 the whole power 4 by 4. So this will give us 3 power 4 is 81 by 4. Minus 1 power 4 is just 1 by 4, which is 80 by 4, which is 20. So that integrand part of the expression is 20. Now I'm going to put it over here. Right? We are solving for xj of 2, and hence we got the answer for xj of 2 is 20 plus 7, 27. This is the final answer. Okay, and you should show this use substitution too. And that's it. This is the wrap. Yes, we complete all the 4 parts over here. And here. That's the wrap for FRQ 5 we have solved today. And the next to last question of the series, you can get it very soon. So until then, you can keep learning and make sure to post the comments, or if you like this, you can subscribe to us. And if you like to be a part of our student WhatsApp community, the join link is in the description below. So you can come connect and ask questions and stay motivated with us. Thanks for learning with Let's Unbound. See you in the next video. Until then, keep practicing.